Everybody, welcome to the plenary panel session. On this slide, you see the title of the session. As you see, in this Congress, we already have a lot of excellent talk, discussion about the AI application in services. And look at a very specific view as well as a broader view. For this particular panel, this is our focus. We talk about the future trend, what kind of strategy advances in service computing using AI technology. We have invited 4 very outstanding, distinguished panelists, and I will introduce one by one at the end of my remark. Let me first give you some overview. Next slide. Okay. Let's look at the broader picture and some history. AI has been exist for at least 50, 60 years. And many universities have AI courses. And right now at Arizona State University, we have in the computer related area, we have more than 10 faculty members. And every semester we offer AI related courses, not application, AI related courses, at least 5 graduate courses and 3-4 undergraduate courses. In fact, our school name has been changed from the original School of Computing, Informatics, and Decision System Engineering, which really include the formal Industrial Engineering Department. The 2 departments merge. And now we change to Computing and Augmented Intelligence School. Augmented Intelligence. And so, because when we go to conferences and talk about all the high-tech area, our not just related to information science, information technology, in our daily life, everything is smart, intelligent, iPhone, right? So the intelligence is the important thing. And well, now we reach the stage that a human intelligence, artificial intelligence, and should be effectively used to have our further advances of our science, technology, and application and industry, products, services, everything to improve our daily life. But why? Now only during the last 10, 15 years or 20 years, all of a sudden all this come up. Although AI, the research had been existed for a long time. That's because there are other areas, technology areas, have a very rapid progress and reach to the stage and it can enable artificial intelligence put it into practical use. The most important aspect, of course, is the computer paradigm, system, engineering, the hardware, software, architecture, all those things. Of course, when we talk about this broader area, that include microelectronics to make the hardware much more effective and efficient and high speed, and the software, including the algorithm and so forth. But our science technology in the information and computing area spread very broad in different branches. So I lumped the first one is the computing paradigm. And then let's go to deeper. Then, of course, a lot of computation. computing. That's why not just talk about computer science. So everywhere now talk about computing, and some university have a school of computing. And the algorithm always there, how to make effective computation and handle complexity analysis and so forth. Certainly in AI, a lot of the computing, and so we have a neural network, and then a lot of efficient and powerful algorithm got to develop and push the advance, drive the advances. And then, of course, the also equally important, or maybe even more important, visible important, is the data. Because if we just get the model, algorithm, and a computer, if you don't have the relevant data, you cannot really tie to the real world and a practical application. Well, of course, data also got a very rapid advances during the last 20 years. But what we talk about the data is not just a big, it should be smart, relevant to what we're looking for. The whole universe we're in, the society we're in, and ranging from personal business to society business to national business and commercial business, everything, right? And the sensor and the continuous flow in the data. But if they are not relevant and we cannot find them, cannot use them, then it's not very good use for future progress. But I think this has been make a very good progress. That's why this is one of the major reasons that AI become practical, not just talk about wishful thinking and to simulate human brain, the smartest brain in the world. Use computing and use AI technology and try to put it in practical use. And then, of course, the communication, distribution, and everything, internet had a major impact. And the mobile network make the communication very convenient. And a sensor continuously collect the data, information in our surrounding, as well as our system and specific areas. All this is very important, but I want to emphasize the last one, semiconductor technology. Well, we know microelectronics, right? And we have all the powerful computer and so forth. We know that. But why we still talk about semiconductor? Right now, how we can make use of AI technology and with the enabling technology like a database, smart data, and internet, and computation together, and put it in various places. Give you an example. Everybody have an iPhone, and go further. Then we have an electric car, and an electric car, everybody know that will be the future trend because that will get a lot of benefit and it can replace a human effort for driving and to conveniently control their living environment and many other things. What's the bottleneck? How to make that real? You need a chip which include all the computation, all the storage and the interaction, and also the analysis using AI technology, put it in practical use. We probably already know. Well, semiconductor has been very successful, progressed very, very fast. And that's why we have all these new product and new services and a lot of advances. But now, how to put into manufacturing. I think we have two panelists already gave their keynote speech, and I will discuss a little bit later on. And here they have further vision in this area, okay? And we feel, I think the whole world feel the major pressure from all these enabling areas. The one probably had the most serious and visible constraint to the further improvement strategy advances in the service area is the semiconductor. Okay, next slide. Okay, so I already talked about this, artificial intelligence, and how we should drive the strategy advances for service computing, and the service computing drive the the various product. Next slide. Okay, it's my great honor to have this four distinguished panelists. The first two, I don't need much introduction because they already gave their keynote speech, especially Roger just gave the speech before this session, and I listened the whole thing and the discussion, very outstanding. And there we listen to your further remark on this related area. Jian Li, the second Jian Li, he is currently vice board chairman of the board, as well as a board member of Foxconn Technology Group in Taiwan. But actually, he is on leave from University of Cincinnati. Okay, he is an Ohio eminent scholar and Scott Arthur Chair Professor at the University of Cincinnati. And he has a very extensive both industry career as well as government. And he started with his work after education. He worked for McKinsey and consulting, as well as the United Technology Research Center played various leadership role. And he also worked for NSF, and that's the first time I met him. And in charge of the NSF Industry University Collaborative Research Center. He established one of them after he joined University of Cincinnati. And recently he had published a book very relevant to this panel, Industry AI, and we will hear his opinion. The third panelist, Bhavani Saranting, you probably met her in the past Congress as well as other conference, and she is the founders chair of computer science at the University of Texas, Dallas, and currently she is the executive director of the cybersecurity research and education institute at the University of Texas, Dallas. She's very well known and gave a lot of keynote speeches in country and in other local events. And also she's very active in the area of promoting women, underrepresented minority, equality, and inclusive. And she's got a lot of accomplishment. Also received a technical award. I think she's an IEEE fellow, ACM fellow, and also the IIAS fellow. And the last one is from South Korea, KAIS. he currently is ITC chair professor in computer science in the School of Computing at Kaiser University. She served as a department chair of computing before, and he currently also is the director of software center at the KAIS. And he has been very active in organizing conferences as well as in the education and research. And he served as the general chair of the International Software Engineering Conference last year in Tokyo. So with the introduction, and we are going to have each panelist give their opening remark in this order. Richard, will you start first?
Thank you, Steve. I appreciate it. The kind introduction to the panel, and really a nice setup for hopefully a lively debate we are going to have. So I'm just going to share the screen briefly so that we can see the remarks. Window, services panel, share. Okay, good. So my remarks, the brief 10 minutes remark, follow the keynote that I just gave as well. So for anybody who wasn't able to follow that, please follow that on a recording. But it's really about something that has already pervaded the entire industry and our society, which is software. And the remarks really are on, thoughts really are on what's next in software. Obviously, I think it's needless to say, software has a major role in our lives. And everything that we know software driven, software defined and software driven, things that you can't even think about are software driven. We are so dependent on software for our day-to-day activities now. Interestingly, as Steve pointed out, AI also has now been playing on that journey to play a similar role in our lives as well. But what we see on the horizon is the world of AI and software starting to collide. And we believe, and more articles are written on it, and that's what I'll take you through. We believe AI will have a major role in software. I think it was Anderson Horowitz who said it at the end of last decade. Software is eating the world, and I think it'll be fair to say AI is going to eat software. And a question that has been long on computer scientists' mind, in fact, AI started with that perspective, was can computers program computers? And that's the question we are going to debate and ask, because of the critical role software plays in our society and the critical role AI will play in our society and is playing in our society on, can AI write software itself? So can AI write AI itself, and more importantly, broader applications? So if you look at what are the three main things, if I were to point out three main things that went into the more recent incarnation of AI, as Steve said, this has been in many decades in making, 5 to 6 decades or so. But obviously, there were three major underpinnings of this. There was obviously data, where it all starts from, algorithms, where a lot of innovations happen, and then married with semiconductors, as Steve pointed out. Lo and behold, GPUs happen to be there. They were not designed for it directly. They happen to be there, but the marriage of these three led to what we now know as the latest breakthroughs and latest and greatest in deep neural networks. But if I were to point out one pillar among these that was most critical, I think I'll point out data being the most critical. Let's talk about that a little bit more. The machine learning revolution is fueled by data. And if there was one data set I can point out that really led to a lot of that frenzied activity, tremendous innovation, I'll call that data set ImageNet, done by Professor Fei-Fei Li at Stanford. And when she rolled it out roughly in 2009, it had 3 million images and 5,000 classes. When all said and done, it ended up in 2012, roughly almost a decade back now, 14 million images and 22,000 classes, capturing all kind of data. And that has been pivotal in really giving rise to a lot of innovation that has taken place, resulting in human level ability in certain narrow tasks, I would say. So for example, from computer vision to where on that particular data set, we can achieve superhuman accuracy, better than humans, but on a narrow task. So I want to be just qualifying that comment with, this is still on a narrow task on that benchmark. On the right-hand side, obviously, that has led to, obviously, when we started with that on that journey, what's in jeopardy in the language area, and more recently, obviously, given all the advances that have been made in NLP area, leading up to the one we focused on a lot was Project Debater for a machine to be able to debate humans for pros and cons. And this was published on the cover of Nature magazine, arguably one of the most prestigious, actually, general science magazines, on Silicon Soapbox and Project Debater. So we have made a lot of progress in years past. But while all of this was happening, I think another problem was brewing as well. I think a lot has been said about physical infrastructure of some of the developed countries, the decaying physical infrastructure. But there's another parallel problem brewing as well on the aging software infrastructure, which is an urgent need of modernization. And interestingly, it is exemplified best by some of the most recent articles on COBOL coders needed for coronavirus fight. And with the language of COBOL, which is underlying lot of infrastructure of governments, services that are delivered, social services that are delivered, with a language which was pretty much invented back in 1960s, so almost 60 years back now. And by some measure, 220 billion lines of legacy COBOL code is running a lot of this. The problem is there's nothing wrong with COBOL per se. I mean, it runs fine, actually. But the problem is in the skills gap, that people who know this language are they're either retiring or have retired already. And it's hard to find people who can take a look at this, address it. Therein lies this aging infrastructure issue that we are dealing with. And this was published in IEEE Spectrum. We had actually a discussion on it, and they captured it as well in one of the issues in October last year of Spectrum on IBM Watson's next challenge, modernizing legacy code. And this was a motivation for us to look at what is a really practical use case of intersecting AI and software. And if I just step back now and look at it from a science point of view, symbols allow us to acquire, represent, share, and communicate knowledge. So symbolic representation has been critical in human evolution from the very inception of when we came on this earth all the way up to now. We have been abstracting human knowledge, how we acquire it, represent it, share it, and communicate it in various different ways. So that we can reason over that knowledge to generate new facts and guide our actions. That's really been our goal all along. Now, languages have been fundamental symbolic systems to which humans have communicated. But there are many other languages. It's not just the language of human communication, actually, just the spoken languages through which we communicate with each other. There's language of chemistry, which is on, there's a symbolic table, there's molecules, there is compounds, there is reactions you can represent. That's all symbolic as well. There's stories you can build, obviously, in terms of spoken languages. There's imagery, which is also language, a kind of language as well. And then finally, there's language of code, software, language of software, which is code, which is the discussion topic actually today of this forum. So let's focus on the code itself. We have seen the power of AI applied to human language. We just talked about it, whether it is voice and conversations, document understanding, speech, you name it, actually. This has made tremendous progress. But if I were to say, what is the language of machines? And I would say code is the language of machines. That's how they communicate with each other. That's how we communicate with them. And we believe, just like AI has helped us master human language, AI will help us master machine language as well, from the point of view of NLP and machine learning for software artifacts, automated reasoning and decision making for software, and really combined with explainable AI as the foundation of it. Now, the question really is, I talked about data in the beginning because that is pivotal to what we do. Now, AI for code, as we have defined this area, needs its ImageNet moment for breakthroughs. To solve tasks like code language translation, code search and retrieval, code similarity, code performance improvements, code memory improvement, code classification, code review, and so on. So what is that, that data? And more recently, in May, we released what we call Project CodeNet. You can go and Google it. You can Google CodeNet, IBM. Enough has been written on it, and a lot more is being written on it as well. And I think industry is really realizing this now as well, that AI for code, AI for coding machine, enterprise applications becomes more and more critical. And this is the first data set of its kind, which is of the scale of ImageNet. It's a very high quality, highly curated data set for algorithmic innovations and benchmarking, large scale, 14 million code samples, over 4,000 coding problems, 55 programming languages. It captures anywhere from Pascal to PL1 to Fortran to COBOL, all the way to C++ and Python and Ruby and Go and Java and others. It's a diverse set of problems and codes. Codes are well tested. There are test set provided for each problem as well, and the metadata is very rich. You can go and take a look at github.com/IBM/Project CodeNet. We also have actually a challenge coming up called CodeNet Challenge, very similar to ImageNet Challenge. And we are working with actually international organizations like Women in Data Science, started out of Stanford University, but they are present in 50 countries across the world, to really democratize a lot of this as we move forward. As I said, it's the largest AI for code open source data set of its kind available today. Please go and take a look at it. I talked about different languages that are present as part of it. It has very rich set of metadata available with it as well. And each of the problem has hundreds of different solutions in many different languages. It also has what problem was accepted, it was not accepted, it had an error, which error it failed, which error it represented. And also, from the point of view of a historical information, Ruchir submitted a solution to this problem. The problem had X number of failures. We will capture that. Ruchir submitted again, 10 days later, another version of that, a solution to that problem. Now we know Ruchir submitted X, it had certain issues. Ruchir submitted Y, it has lesser number of issues. Since I have historical information, I can learn, I can train a model actually on what is needed to improve code. So this becomes actually recommendations for code improvement as well. We've also been working on a very sort of a prescriptive stack as well. Again, a lot has been captured as part of the archive paper also, that you can take a look at it. From data to intermediate representations to NLP technologies to some of the key capabilities of understanding code, reviewing code, retrieving and generating code, and most importantly, testing code. And applications are built on top of it. I'm just going to take 10 seconds and really give we've been working on capabilities to marry AI for code with modernizing legacy code. This is actually just an example of one of the key clients. This was a $200 million application with a large automotive client, 3,500 plus Java files, more than 1 million lines of code, built over multiple generations of Java technologies. They were trying to do this for several years, actually, almost a year, to modernize this, struggling with it. And some of the technologies that are captured as part of AI for code were able to do it roughly in 4 weeks to give the right set of recommendations. And finally, I'll close with, it's really about data, married with the set of technologies that are brought together as part of an AI for code algorithmic stack, and really delivered as a business value in certain key use cases for example, for modernizing legacy code and boost developer productivity. And just watch out this space. I think this is, if you just Google this, you will find a lot more information on it. It's becoming an exciting area for research. And just like software has really disrupted in many ways our lives and made it richer, I believe AI will disrupt software as well. So I'm going to rest my remarks and really looking forward to rest of them and a lively discussion.
Oh, thank you for your presentation. Jerry, you are in Taiwan, midnight now, right? After midnight. Will you please start your presentation?
Yes, thank you. Okay, can everyone see it?
Yeah.
Okay, yeah, thanks for the panel invitation. I think this is a good subject to discuss. I will finish it up in 10 minutes. I used some of my keynote slide, but I'm trying to reframe it based on the panel's purpose, right? So when we're talking about service computing for the future, for especially now I'm talking about industrial system. Industrial system is a purpose. It's not for fun, it's a purpose. So the purpose means you gotta have the value creation for customer, and also you gotta have a bottom line to meet the efficiency, reliability, and certainly you wanna build some productivity issue. So I think that's, of course, when we build service computing in our industrial system, normally there are several approaches. The most common approach, right, today, embedded, XYZ on chip, mission driven, in special equipment, in special surveillance systems, in the vehicles. For example, we recently acquired a company. We start making silicon carbide chips for the EV modules, for the onboard charging, and also for the inverter, right? But that's the future. The second thing is we have lots of assets worldwide. The edge-based service computing for any asset. Could be in a machine tool, could be robots, could be injection molding machine, right? Could be a chiller for the foundry, and could be a vacuum pump for the foundry. So such a things, edge-based. Now fog-based, we have a similar machine, the same cell. Right? We have to be able to integrate them together rather to use just individual edge. I call it for cluster of machines. Then cloud-based, we have a remote, we have a customer want to share, we got a user have to do. And then cyber-based, wow, I'm talking about large scale and complex asset, right? So basically this is a few different ways. And obviously it doesn't matter what we do, and I think the keynote I talk about it, every product we build, and it doesn't matter what company you have, the product future have to be self-aware. That's gonna trend gonna be. Second, operation-wise, you have to be able to optimize, predict, avoid problems. The third, you gotta synchronize because you're enterprise level. So in the asset level, you have self-aware. Operation level, you gotta have a predict, optimize, prioritize. And enterprise level, you have to able to reconfigure and eventually and to minimize a lot of risks. So by that, I talk about it. Doesn't matter what we do in service computing, we have to move from the visible problem space to a problem avoidance space, right? I talk about that. But eventually, those invisible problems are the one we need to work on. That's called resilient purposes, right? And so based on this, I think as an example, that many years ago, we started working on a machine. For example, bulldozer machine, during I said, when we build such things, the algorithm has to be working on machine side rather than remotely collect. So eventually we can build such a distributed asset and put embedded system and the edge side, so the data can be converted to predictable information. Then you can allow user to manage an asset, but that's what we're talking about. But obviously that's not the purpose only. The purpose means you don't have a one machine, you have a lots of machines, right? So for me, the smart service computing for large fleet system is going to be, what's a fleet about, right? We have aircraft engine, bulldozer, and EV running around. The batteries, how we minimize the degradation based on user driving behavior, weather, and as well as the vehicle the conditions. So basically, the different way we're trying to integrate now from the enterprise level service computing is based on methodology. So based on this, I think we have normally we use a fleet. So in fleet-based system, obviously is what we use most frequently, right? When you have a large fleet systems, how you physically can manage in those risks and also the a resilience. That's a lot of methodology we're talking about. You can also all sorts of new stuff, but regardless, but somehow you have to reach the bottom line. Bottom line, I mean, customer have to come back to buy things from you, or you just sell once. Okay, so eventually we're talking about fleet-based. For example, we got lots of robots in the factory. We have a new way to cluster them. Eventually, we can evaluate by comparing them. Every day we run a 5 minutes pattern. We know exactly which robot is the least performing. Then we focus on the robots. We don't have to monitor all the robots. Like a Toyota plant in Georgetown, Kentucky, there are 2,000 robots, right? So eventually, let's give one example. Well, I see the future manufacturing, right? Especially we do manufacturing, service computing, because when we have a large machine connect together, and we start building the edge and frog system. So frog computing is one of the things we've been building in Foxconn, because we have a lot of similar machines. That's a problem, right? We use hundreds of machines produce your iPhone, right? So, but as when you have frog computings, what do? You have to able to predict the machine. Rather, like left side is our traditional factory, right side is our predictive factory. You can turn off the lights. Workers don't have to run around. Your phone itself can be predictable. A system allow you to focus on how to minimize and optimize your manpower and also a priority. So this is another toy. It's real. But we see the future cyber computing is that any factory around the world, we're trying to build the cyber digital twin space. So the reason we call the service computing for resilient manufacturing, because we have the service, our customers, our factory. Also, we have to help our suppliers achieve the same productivity, even better. But to do that, and our scalable, we call the scalable platform, had to be reused over and over again. We cannot build every factory, every facility, every asset have their own computing system. Impossible. So in the end, we are focusing right now. The future is called the stream of quality methodology. So we can trace quality of our products, not just from the factory, and also from the logistics, and all the way to installation, right? But depend on what the industry you are, of course. And same thing for the battery, the end of EV life, and you have 20% degradation. But over the time, we know how the car drive and how many miles you drive, what kind of condition you drive, what's the weather changes, the environment changes. Those are blockchain and label those changes. Eventually, nobody can erase. So I know exactly what happened to your product in history. But again, there's a DNA, right? So in the end, we're talking about a different type of computing inside the modules built into the smart battery and smart machine. And eventually, that's what we have called the overall historical view. Finally, I think the role of industrial AI, we believe that the service computing, one of the challenging things in the industry is the quality system of data. How you value the quality of data from a source, from the history diagnosable, and from the future predictable. So you have to train the system, make sure everyone train the system is the same. And today it's very challenging for industrial system. You have two engineers, give them same tool, same data sets, two different results. I think we know why, because the feature selection is different. But again, if you cannot validate from the previous problems, then we cannot do it. So again, I'm talking about systematic approach, how we deliver future service computing in industrial settings. Anyway, so this is just a summary, and we can discuss later. Thank you.
Hey, thank you very much, Jay. Next panelist, Bhavani.
Yes, thank you very much, Professor Yao, for inviting me to serve in this panel. And so my focus is going to be, how do you integrate artificial intelligence and services? And then by services, I also include web services, right? So web services really has been my main focus. And so the topic is really, how do they help each other? So in particular, how can we apply artificial intelligence for services? And then how can we apply services for artificial intelligence? And so since cybersecurity has been my main focus, I'm going to look at AI systems that are being developed to solve problems in cybersecurity. So again, first I will talk about how can services computing, help with artificial intelligence-based systems, and then how can we apply artificial intelligence in general for services computing, which also includes web services. Next. Right. So as I said, I've been given 10 minutes to present. So I'll take a few minutes and talk about how services and in general web services can be applied for AI systems. And in particular, what we mean by AI systems is AI systems that can be applied. It could be medical-based AI systems or AI systems for financial applications, AI systems for manufacturing. And in my case, I'll talk about AI systems for cybersecurity. So in our work, we have applied AI systems. In particular, what I mean by AI, it's more machine learning. That's been my area of research, applying machine learning to solve a variety of problems in cybersecurity. That would include intrusion detection, website fingerprinting, and in here I talk about insider threat detection. So that's one application of one aspect of cybersecurity. So what did we do? We developed this machine learning system. So in general, initially we did not sort of use web services. So this was our initial architecture. So essentially what happens is that you have some person, right, typing in. So what do we mean by insider threat? That means bad people pretending to be good people, right? And they could carry out espionage. But we are more interested in bad malicious processes. They pretend to be good, benign processes. And so it could be sort of in a database process, it could be even in a compiler process, whatever, but they are malicious processes. So again, the humans are sort of typing in all kinds of commands, system calls, and so on, but some of them could be really malicious. So typically, as in machine learning, we take the I chunks, right, extract the features, and then apply these machine learning algorithms and train the models and so on. And then when the I+1 chunk arrives, we do the testing. So what has been unique about our approach from a machine learning point of view is that we develop an ensemble of models, meaning that a collection of models, because see, one day it could be in a financial application, say, it could be by Microsoft. Another day it could be by IBM stock. Another day it could be by Facebook or Google or Amazon and Apple. So streaming data is coming in. So again, network traffic data is very similar. Streaming data and the concepts are changing very rapidly, right? So we develop an ensemble of models. Over time, some models could be really bad, meaning that some models could be outdated, so we throw them away, and some other models could be replaced, right? So bad models meaning outdated models, because the concepts are changing continuously. So that's the challenge of our work. And we developed supervised learning, unsupervised learning, and then we had very low false positives, false negatives, and very high accuracy. So the next step that you can ask, remember, my question is, the point is, how can services help, right? So first we develop this one big monolithic system, okay? So the next question that for many of our projects now, and in fact, one of my students and I are working on bringing in services to develop complex machine learning systems. So how do you break this machine learning system apart, right? So you can have a collection of services for training, a collection of services for selecting the correct models, so updating the ensembles, and then the collection of services for testing, right? So training services, that could be, again, feature extraction service. We could have development of ensemble of models, and then throwing away models. So you have one big service and then decompose into smaller services. So that's where services can help these AI systems. So in particular for us, it's machine learning systems. We believe that we can also apply for other types of AI systems. That could be planning systems or automated reasoning systems and so on. And again, since we do a lot of work in machine learning, we are applying services for machine learning based systems. And one application that we are focusing here is cybersecurity. Okay, so that's services for AI. Next. Right. So this is where I believe the future is going to be, right? Because how can artificial intelligence be applied for services, right? That's where the challenge and plenty of opportunities, lots of opportunities for research. So what are some of the applications where I see? First is, how can we apply AI to specify and design services? That's really a challenge because, earlier I've been attending Services Congress for about, I think, 14, 15. Actually, I was there for the first one, 2004, for 20 years, 17, 18 years, and then very regularly since around 2018. And so earlier conferences, we talked a lot about designing services, right? You have this big service, how do you decompose them into services? And I believe that IBM was a leader on service-oriented design, just like object-oriented analysis and design, there was service-oriented design. I believe that in this area, AI could be helping us because the real-world applications, and again, the previous two speakers really gave very good information about large-scale systems, right? So when you have these large-scale systems and then bring in services, right, you have to decide how to decompose these services, how to compose these services. And that's where I believe that AI systems can give us advice, right, on how to decompose and compose services. So that's one area. Another area, because I work in cybersecurity, one of the main things for us is the consistency of policies. What are the appropriate policies for developing these services, especially from policies, for me, from a security point of view, right? We can just randomly, develop all these policies, and these policies could be all inconsistent. And so when you develop secure services, in particular, secure web services, what sort of policies give guidance on the appropriate policies? And are these policies, so if I talk about one policy where two services should not be combined, and another policy that says, no, these two services should be combined, there is this inconsistency, right? So how can AI be applied to check for the consistency of the policies and services? And these policies could be security policies, they could be integrity policies, they could be trust policies, they could also be privacy policies. And so again, bringing AI to reason about these policies that are being applied for web services and coming up with the appropriate set of policies. So that's number two. Number three, how can AI be applied to detect security violations in services? So 2 and 3 are somewhat related. So here we can use a lot of work that has been carried out in automated reasoning, right? So there is automated reasoning for inference problems. So what is inference problem? Inference problem is where you put collections of public information or unclassified information, put them together and infer something that is highly private, highly sensitive, highly classified, right? So I've been working on this problem for a long time, and ever since I started my career in cybersecurity, which was back in 1985 at Honeywell. And so automated reasoning techniques, we started using them like for inference problem. But these problems also exist in web services, right? So security violations in web services, not just policy inconsistencies, but you reason about these services and then find that, okay, when you mix and match these different services, and because this could very well be web services, then that could lead to some kind of an inference problem, right? So that's another area. Fourth is, this is now becoming really, really important. How can AI be applied for the verification of services, right? So verifying software has been around, for a long time, right? Since probably, 70s, there's been formal verification techniques and so on. But now we are at a time that these web services also need to be verified, right? Formally verified. And so in this case, how can AI techniques, in particular, the AI techniques is logic-based theorem provers. Some may not consider logic-based theorem provers as part of AI, but they really started as part of AI. Back in the 70s, when you read the books by Chang and Lee, right, they talk about theorem provers, which was taught as part of AI classes, right? So how can AI be applied for the verification of services? Another area somewhat related, not direct, there's a whole new area that is developing, and that is formally verifying the AI systems themselves, okay? And so that is also a big problem in terms of the AI systems or the AI techniques have to be secure and they have to be verified. That's a separate area. Here I'm talking about applying AI techniques to verify these services. And the last point I want to make is, how can AI be applied for developing these intelligent services, right? So here, the web services have to carry out intelligent actions. And so machine learning or AI are incorporated as part of these web services to make them more intelligent. And they could be applied, say, in the finance industry, in medicine, in manufacturing. And so there's whole other area, of course, all these IoT systems, which I'm not even including here, because that's something that we are focusing on right now. How can we bring AI and security and IoT in there? So we haven't done a lot of work for me to be confidently discuss those aspects, but those are some of the things that are coming into the future. But again, this is my last chart. So the focus again, how can services help AI systems? And how can AI help services? And that also includes web services. And I brought in cybersecurity as an application here, because cybersecurity is what, my main area for the last several years. So these are three: AI, services, cybersecurity. All three, for me, are closely integrated. And again, thank you. Looking forward to the discussions. And that's it for me.
Okay. All right. Thank you, Bhavani. Our last panelist, Yuan. Are you ready? You are from South Korea. 2 o'clock in the morning, right?
Can you hear me?
Yeah.
Okay. So let me start. I'll try to finish within 10 minutes. Okay.
Yeah.
So, hello, I'm Duanbe at KAIST. It is my great honor to participate in this plenary panel as a panelist. I'm going to talk on AI policy and industrial application in South Korea. So, in this talk, I'll address the three issues. First one is a national manpower training strategy for AI in South Korea. As you can see in this figure, this one shows AI competitiveness with respect to AI technology development and AI application deployment capabilities. I got this figure about a week ago from the National Academy of Engineering, Korea. In this figure, the countries are classified into 4 groups. So on the right-hand side is the champion group. Well, there is no doubt in this group, United States and China are positioned. Also, in the rightmost group of the left-hand side, South Korea, together with Japan, Germany, UK, France is in its aspiring leaders group. South Korea has very strong industry background, including its heavy industries, such as shipbuilding and steel manufacturing. Also, South Korea has many well-educated human resources and strong digitalization infrastructure, and the government wants to continue its industrial growth by promoting AI use in all the industry sectors. So government understands the first thing to become such a leader is to educate human resources in AI. So this is national AI strategies and policies for 2030. So it starts with a vision, AI for everyone, AI of everything. So it has 3 goals. The first one
Yuan, we are not seeing your next slide, so I just wanted to point that out. Maybe it's the same for others too. I don't know.
Well,
we are still seeing your title slide, actually.
You didn't see this, the National Manpower Training Strategy for this one?
No.
Can you hear me?
We can hear you, but we're not seeing your next slide. We are still on the title.
Slide not moving.
Yeah, you only have a cover page. That's the only thing you have. Yeah.
Oops. Well, I can see the page 3 now.
But not on our screen.
Oops.
I think you can close it and I think the staff can play for you. That may be easier.
Let me call.
Okay. Luca, can you move my slides?
Yeah, he's bringing it up, I think.
It was just fine in my screen, though.
The thing is, we couldn't see, right? That's the main thing.
Clark, are you there? Clark Chan.
Yeah, it's okay, actually. I think we got it
now. See now. Yes.
Okay, can you move on to next? Okay, so here, okay, let me try with this, okay. So, well, the first, the vision is AI for everyone and AI of everything. It has 3 goals established. And the first one is to become the third in the world for digital competitiveness. Currently, South Korea is 10th this year. Second one in the middle is to achieve the economic effects, up to about the 380 billion US dollars. The third is to become the 10th in the world for quality of life. Right now, the South Korea is about 30th. To achieve these goals, we established the 3 strategies. The first one on the left-hand side, building a world-leading AI ecosystem, and the countries that use AI the most in the middle. And third one is implementing human-centered AI. So one task under the strategy of countries that use AI the most in the middle one, I just marked in the red box, is a national HR, human resource education. So, well, can you move on to next? All right, so more specifically, the government wants to innovate education system to enable citizens to use AI. So Ministry of Science and Technology and ICT is going to invest about $1 billion US until 2025. And it wants to solve the problem of AI and software human resource shortage problem. In 2025, we expect about 2,000 master and PhD graduates per year who are specialized in AI will be produced, and another 8,000 professionals per year will also be produced. Next. Okay, so how to achieve these target goals? So, well, there are 2 key projects sponsored by the Ministry of Science, Technology, and ICT. So the first one is called Software Initiative Universities. So the program basically encourages more students to select computer science or related areas as their majors, and they try to help the many other activities, such as enhancing educational environment and helps the students get the international experience through their internships and student exchange programs. Also, teaching the programming courses to non-computer science major students also provides programming training to public as well. So this project started in 2015 with 8 universities, and now we have 41 universities are supported by this project. 41 universities means about 20% of the South Korean universities are participating in this project. The second one is AI graduate school program. So it will produce master and PhD graduate specialized in AI. So it started in 2019 with 3 schools, and now we have 14 of them. Okay, next. So I showed you this figure again. So I'm moving to the government project or policy related to industrial use of AI. So to promote the use of AI in all industrial sectors, you see in the middle, the red boxes, there are 2 main tasks. So one is fostering startups, and the other is AI adoption by all industries. Next. So government launched 2 projects to do so. One is called the Digital New Deal. So here for AI promotion in industry, government realized that the use of data, network, and AI is essential. This project started last year in order to boost the weakened economy at the time due to the COVID-19 crisis. Its estimated total budget for this project is up to 49 billion US dollars by 2025. Another interesting project in the middle is the Data Dam project. So as you can easily imagine, this project is to make data available for new business innovation and new job creation. Those data sets collected in the public and private sectors will be made available for AI application development. Next. So there are industrial sectors identified as potential AI application domains and its corresponding goals and projects. I'm not going to explain in detail, but I'd like to share one interesting example on cultural content. You see there on the right-hand side that the lady shown, okay? So she was shown in the TV advertisement several months ago. At the beginning, most of the people thought that she was a real person, but in fact, she's a virtual human being, and then developed by a company. So her name is Rosie, and she is very popular among young generations. A good thing about her is she is always 22 years old. She's dancing, she sings a song, you know. So she works as an influencer with more than 10,000 followers in SNS as well. So now she's making a lot of money. Has more than 100 sponsors. Next. Okay, these are the industrial applications in South Korea. So let us start with the Hyundai Shipbuilding Company. So the company wants to become the first ocean-going autonomous ship manufacturer. The company worked with a small company to develop a supporting system for autonomous voyage. So it developed the HINAS and HIBAS. HINAS is for intelligent navigation, and HIBAS is for intelligent berthing. So it plans to deploy this system on a 985-foot long LNG carrier by the end of this year. So not just the Hyundai, but Samsung and Daewoo are the other shipbuilding companies in South Korea. They are using AI technology in various ways. So you know that the shipbuilding is really a big business, covering most of engineering areas. And so they try to use AI techniques to solve their engineering problems. So KAIST's education center is also working with them to train those practitioners in AI. Next page. So this is another example, application example in South Korea. So the steel manufacturers. The Ministry of Trading, Industry and Energy is supporting the project called the Steel AI. So it tried to use various data produced during steel manufacturing for improving efficiency and safety of the factory as well. Frankly, I'm not familiar with these projects, but it seems the Steel AI platform becomes a major component of this heavy industry. Next page. Next one. Okay, so through this project, the POSCO, which is the largest South Korean steel manufacturer, was recognized as the first lighthouse factory by a World Economic Forum. World Economic Forum actually announced the 10 such lighthouse companies every 6 months, and POSCO was selected as one of them. Actually, it saved a lot of money already. And I had another example, like a Neighbor, the Clover lamp. It is called Clover lamp. Neighbor is like the Korean Google. It started with the searching, the internet searching, and it developed the lamp, Clover lamp, which is the integration of the AI speaker and lamp. It just read a book for the human being. Okay, so while these are some of the application industry in AI industry application in South Korea. Thank you for listening. I'm sorry to those the presentation was not smooth in the middle, so I cannot see that the small letters by myself. Okay.
Oh, okay. Can you hear me, Yuan?
Oh yes, I can hear you.
Okay, you finished, right? Thank you. Okay, Carl, we received some. I think we open the discussion. Any question from the audience first? Carl?
Yes, I'm here. I'm trying to capture any questions coming from the audience, or the panelists can ask questions to each other.
No. Have you received any question from the audience?
Not at this moment. Not yet. We just opened the floor. Yeah.
Okay. All right. I encourage the audience to submit your question fast, because I understand we have probably only 10 minutes left. All right. Before we receive any question, I have a question for some of the panelists. Jay Lee?
Yeah, I'm here.
Okay. Can you share with us some of the recent activities? The company you joined, Fox Group, Technology Group, got a lot of investment going on in China, in United States.
Yeah.
What if you can share some of the information?
Yes.
What's the collaboration or investment in United States? I know you have a big plan, right? Your company.
Yes, we Foxconn has invested a big a smart manufacturing science park in Wisconsin. It's about 2,000 acres. The science park. Certainly, there are several major activities. One of the major activity related to this panel is our high performance computing (HPC). As you know, Wisconsin is well known for agriculture, for manufacturing, right? And also for healthcare, medical. Those are three pillars. But the future, if you look at the how AI applied to industries, now the precision farming system, right? How to grow the crops and make better cheese and those things. So eventually, we believe the future manufacturing, same thing. They need. I agree with the AI as a service, which is believed important, but the HPC computing is also service, right? Because of the data, most companies, they have a difficulty even to find the right data. Just forget about to apply AI, right? So they don't even know what data is useful and what data is usable. So the fundamental discipline is not even there, right? So basically, we have smart manufacturing we build there. Also, and then the one thing you probably have heard, a lot of news, we'll be making EVs with Fisker in US, right? And starting and major production will be out in 2023. So this is in the future. We have a battery cloud connect to all the EVs as well as HPC, and so embedded systems, and also silicon carbide, how they have onboard charging, also inverter, and can predict the system. So all the things is coming. Yeah.
Oh, very good. Carl, have you received any question from the audience?
Not this moment, no.
Okay, then let's continue our discussion. Any other panelists?
Right. So I have a question, Professor Yao. So again, the panel, I really liked all the presentations from the other panelists. So my question is, where does sort of services come into it, right? Most of the panelists talked about, the plans for AI, and without a doubt, AI has so many applications and so on. So how do we sort of integrate? That's what I was trying to sort of present. How do we integrate AI and services? So in one of your applications, any of the panelists, if they can talk about, I think there was some discussions about manufacturing. So how do you bring in the services and AI and this particular application? Some examples, if that will really help.
Well, Bhavani,
Yes.
you missed some of the good speech, or Jay gave exactly a topic about how to integrate AI in manufacturing.
Oh, right? In the keynote address. Sorry, I missed it.
Okay, but let me tell you, from research community, it's easy. Academic community is easy. As I say, our university already changed our department name to computing and augmented intelligence. Let me tell you, I talk about, we have about 10 faculty, they are doing research in AI. I'm not doing research in AI, but I use AI, and I already cover every course I teach. I use a machine learning, and not just a machine learning, other new technology like a blockchain too. Okay, so from research and education point of view, we should take advantage of whatever available and most useful and powerful and productive to get our result. Now, machine learning is the most obvious and the most visible thing in not just my course teach, other courses my colleagues teach too. I'm sure Carl and Yuan in your university the same thing. Okay, so we integrate, but I think from industry point of view, Jay Lee gave a very good talk and talk about how he's doing in the intelligent manufacturing and maintenance and the whole system. And Richard, you're IBM involved in everything. So maybe you can also share some vision, which areas, the title of this panel, we emphasize strategy advances, not advances all the direction.
I think some of so Bhavani, some of the most important areas, I would say, where AI certainly has, those are at the leading edge, let me say, financial services. Yeah. Certainly at the leading edge of incorporating AI. Obviously, in transportation and in like retail. Is another one at the leading edge of infusing AI as part of their applications. But one thread that is emerging as a common among all of this, and as we all know very well, every services is becoming software services, because everything is, whether it is hardware or infrastructure or transportation, it's defined by software. Yeah. And to a large extent, the task of service professionals is becoming as integrators and deployment of those services, monitoring of those services, integration of those services. And this is why I talked about the software aspects, because development, staging, and production of the software services, delivery and monitoring of them is the key aspects where I believe AI can help as a normalization across various industries. And how we operate these services as well. And this is where I think cloud technologies are becoming increasingly important, because it is less and less about obviously on-prem only, that you hold the infrastructure on-prem. It's a mixture of, you have some in the cloud, public cloud, you have some on-prem, some on the edge. And this is where it is becoming increasingly important, which are services are becoming a lot more distributed. And how do you deliver those services? How do you monitor those services? And how do you maintain those services from a software point of view? Because that's how most of the world is being defined today. And as you very well know, and I think the audience know it as well, IBM focuses on this as large part of our business. And I can certainly tell you this, a lot of our business from a services point of view is becoming software defined, software integrated, and software delivery as well.
Yes.
Professor
Very good.
Yao,
Yeah.
Professor Yao, there's a question coming from the audience.
Yeah, go ahead.
The question from Masood Ravinani: what are the most lasted projects or applications in mHealth by integrating AI?
Will you repeat that question?
What are the most lasted, LASTED, lasted projects or applications in mobile health by integrating AI?
Okay. Any panelists wanted to answer that question?
Maybe Lucio give a try.
The thing is mobile health, right? How many of us are doing work in mobile health? But when we were in,
Yeah, that's a one application.
Yeah.
Mobile health and health.
So, I mean, working from home, I mean, we've been doing essentially mobile health, right? Anyway, that's not my area of expertise.
Jay, I think
I think
your company involved.
we also have a health group here. Basically,
yeah.
If you look at lots so far we have a lot of wearable devices already there. Actually, if you look at Apple Watch, already has a basic function there. But the problem is, oh man, and you're not monitoring people. You are trying to help people prevent things from happening, right? So if you look at the future mobile health, not just for senior people, but also for sports medicine as well, right? And we work with a sports medicine people how to monitor the stress and doing the very intensive a sporting behavior and what's the risk to to people, and also for people who on travel as well. So a lot of things we have wearable devices. Eventually, you need to support that function and to predict and also to synchronize with the right doctor in the local.
Yeah.
So not just
this area is fast evolving, and lasted applications is probably be a more speculative question. This area is fast evolving in general, and data privacy and other issues come into this as
That's
well.
what I wanted to mention. Whenever you talk about mobile health, right, you have to consider privacy in there, privacy policies. Yeah.
Yeah, it's not as I think we can always speculate a lot of applications, but as I talked in my keynote as well, there are many other aspects of building, scaled out applications other than ideas, actually, which can certainly be abound.
Right.
And areas fast evolving.
Okay, Clark.
Right. Actually, the correction from the Masood, this gentleman asked the question is not the lasted, it's the latest.
Well, latest.
That's a typo, so that makes sense. Yes.
Okay, Clark, how's the time? We are 2 minutes over, right?
Yes, we can have a chance to entertain one more question if there's any more questions.
Any more questions? Well, just for information, for this Congress, we have a conference and a symposium cover health area, right? Carl?
Yes, sorry, I'm looking at the schedule. Yeah, what's the question?
So I encourage people look at the Congress program. There are conferences and sessions at this Congress dealing with mobile health and that kind of applications.
Right.
Steve, I also want to add one thing. There's also this big area evolving on medical Internet of Medical Things, IoT for medical, IoT for finance, IoT for transportation. That's also an area.
Yes, yes, Bhavani. I think Professor Yao just mentioned that we do have this year. We have an international conference on digital health that covers mHealth, right? And that has been very well attended in almost every session. Yes.
Yeah, well, that's the advantage of have the Congress with many conferences and symposium cover specific areas under the umbrella of services.
Right.
Very good. So, well, if no more question, I think we close the session. Thanks all the panelists. Spend a lot of time to prepare and especially coordinate the global participation for the conference of the panel under the current pandemic constraint and environment. And I thank you, the panelists deeply. And in fact, we have worked on this for several months, not just work on this, put the things together. And very good, we got the good information from a different perspective. Thank you very much for joining us. Bye.
Thank you all.
Bye. Thank you very much. Bye.
Bye-bye.
Thank you.
Thank you.
Bye.
Take care.
Bye.